TK has graduated in Civil Engineering from University UBDT College of Engineering, Davangere in the year 2000 and obtained postgraduate degree in Structural Engineering from RV College of Engineering, Bangalore in the year 2008. She has obtained her doctoral degree in the year 2017 from VTU. Presently, she is working as assistant professor in Civil Engineering Department at Government Engineering College, Ramanagara. She has over 15 years of experience in academics and 6 years in research. Her research areas include geopolymer masonry, sustainable construction materials, and structural dynamics. Ma'am, I welcome you to the conference and request you to kindly from RV College of Engineering.
Thank you, Megha, for the kind introduction.
Welcome, ma'am.
Namaskara, madam. Namaskara.
Namaskara, sir.
Namaskara, Jyoti. Or ಹೇಗಿದ್ದೀರಿ?
ಚೆನ್ನಾಗಿದ್ದೀನಿ, sir. Nice to meet you all.
Thanks. Okay, thank you.
Along with Dr. Jyoti TK, we have Dr. P. Prakash, Professor and Head, Department of Construction Technology and Management, DSCE, chairing the session. Sir has published 22 journals and presented 15 international conference papers. Professor has visited University of Leuven, Belgium, Laval University, Quebec, Canada, and University of Wisconsin. Sir, I request you to kindly chair this session. I welcome you to the technical session, sir.
Thank you, ma'am. Okay. Good afternoon, everybody. There are 4 speakers from 1:45 onwards. Each speaker is given 15 minutes to present his paper. Okay. Now you can start the program, sir. The first paper is experimental study on bond strength of reinforced cement concrete using M sand under corrosion. The authors are Vishnu Prakash S, Dhanren Raj S, Ramkumar K, Gokul P. Now, if you are ready, you can start sharing the paper, sir. Presentation.
Hello, good afternoon, sir.
Good afternoon. Please start.
Sir, screen, sir, not able to share, sir. Post only able to share.
Sir, you can share the screen now.
Now you can share the screen. May I know who's speaking, Vishnu Prakash or Dhanred Raj?
Sir, Vishnu Prakash, sir.
Okay, Vishnu Prakash, now you can share the screen.
Okay, sir. 1 second. Sir, shall we start?
You can start, sir. Please start the presentation.
Okay, sir. Thank you, sir.
Okay.
Good afternoon to one and all present here. Our project topic is about a study on bond behavior of reinforced cement concrete using M sand under corrosion. Our project by me, Vishnu Prakash, Mr. S. Daniel Raj, Mr. P. Gogol, and Mr. K. Ramkumar. Need for the study. Since nowadays the corrosion plays major role in our society in concrete, reinforced concrete, it affects the bond between the steel and concrete depends upon the intensity of corrosion rate. Nowadays the reverse sand availability is less, so we can, in this project we used M sand by replacing of reverse sand. There is a lot of research studies already done to identify the bond behavior of reinforced concrete under corrosion by using reverse sand. Now we used by using M sand. Next objective of the project to determine the corrosion level using accelerated corrosion method to study the bond behavior of reinforced cement concrete using M sand under corrosion by using pull-out test to undergo the comparative study on the bond behavior of uncorroded specimen with the corroded specimens. Next, we use our methodology from start to us literature study, material study, collecting materials, specimen preparation, then accelerated corrosion method, pull-out test, next result discussion and conclusion. Our literature study, our first literature is about bond life degradation of steel strand and concrete under combined corrosion and fatigue. This paper deals with the bond between steel bar and concrete induced by corrosion fatigue damage. Series of combined action of corrosion and fatigue was conducted. The corrosion fatigue failure was mainly present in split mode because of screwing effect of the strand embedded in the concrete. The fatigue process is thought to begin at an internal or surface flaw where the stress are concentrated and consists initially of shear flow along slip planes. Over a number of cycles, this slip generates intrusion and extrusion that begin to resemble crack. The next literature is about the impact of corrosion on bond in uncracked concrete with confined and unconfined rebar. In this literature, the paper deals with specimen with 1 or 2 times cover bond strength increases as corrosion proceeds, with 3 times cover bond strength remains constant. Bond strength decreases with the increase of corrosion level prior to cracking. The bottom cast bars generally have higher bond strength than the top cast bars by providing shear links to increase the bond strength. The next literature is about study of the loss of bond in reinforced concrete specimen with accelerated corrosion by means of push-out tests. This paper deals with the following point. The maximum shear stress in the test is not affected by corrosion depth for the corrosion levels. The residual stress of specimens with a small corrosion depth was greater than that of non-corroded specimens due to increase of surface roughness. Besides, crack widening was greater for specimen with higher corrosion level, which may explain the residual stress of those specimen was small. The next literature is about bond strength evaluation of corroded steel bars via the surface crack with induced by reinforcement corrosion. The corrosion of steel bars in reinforced concrete structure induces concrete cover cracking and leads to reduction in the steel concrete bond strength. It is further revealed that the bond strength decreases exponentially with the surface crack width. After concrete cover cracking, there is a strong correlation between the surface crack width and the corrosion level. When the crack width becomes relatively large, further increase of corrosion penetration has less influence of crack width. For specimens without stirrups and the bond strength drops significantly with the increase of crack width. However, for specimens with stirrups, the bond deterioration is prevented by the presence of stirrups. The next literature study is about bond behavior with reinforcement corrosion. This paper says that an increase of bond efficiency of up to 2% of corrosion was registered in the absence of confinement exerted by stirrups. However, a sudden reduction was observed when higher levels of corrosion were reached, and then only were limited residual bond strength and evidence for increasing levels of corrosion. The confined specimen showed an initial increase in bond efficiency from 0% to 2% level of corrosion, whereas substantially uniformity of bond strength level was maintained for higher levels. The next literature study of bond behavior of steel was made with lightweight aggregates. The test carried out this study calculated method for corroding steel reinforcement and pull-out test for determining bond strength. Test results indicated that the load slip behavior of the deformed steel bars embedded in structural light concrete is dependent upon compressive strength and bar diameter and embedded length. Peak load rebar slip values from 1.2 mm to 2.4 mm were observed in rebar different diameters. The bond strength of deformed steel bars embedded in structural lightweight concrete increased with increase in compressive strength but decreases as bar diameter increases. The next paper is about experimental investigation of corrosion effect on bond behavior between reinforcing bar and concrete. In this, the corrosion influence of bond strength can be ignored when the corrosion loss is less than 2.4%. The bond behavior between smooth bar concrete is more sensitive than the deformed bar. In case of 20 mm rod, the bond strength value of smooth bar is 5.48 Newton per and deformed bar is about 9.05 Newton per mm. The distribution of bond stress is more uniform for the specimen whose corrosion induced crack width is large. The next paper deals with is about bond behavior of steel bar embedded in engineered cementitious composites under pull-out test. In this paper, the ultimate bond strength of plain bar in ECC increased 1.7 times of ordinary concrete. Under pull-out test, steel embedded with concrete showed brittle failure, whereas steel embedded in ECC showed ductility failure. Decrease in bar diameter and material composition is given the ultimate bond strength to the ECC. The arrangement of fiber is reduced the crack width and the extension of the internal crack. After the test conducted, the ECC specimen maintained the tolerance compared to ordinary concrete. The next paper is about evaluation of the bond strength between reinforcing steel and fiber reinforced concrete after high temperature exposure. To determine the bond strength between reinforcing steel and fiber reinforced concrete after high temperature exposure. High bond strength is achieved by addition of fiber in the help of aspect ratio. In normal and high strength concrete, the polypropylene and steel fiber are used to increase the bond strength after the high temperature. From the above literature study, we can take some points that are an increase of bond efficiency of up to 2% of corrosion was registered in absence of confinement except by syrups. However, a sudden reduction was observed when higher levels of corrosion were reached, and then only very limited residual bond strength was evidence for increasing levels of corrosion. The confined specimen showed an initial increase in bond efficiency from 0% to 2% levels of corrosion. Next, the test we used to find the bond strength and corrosion. Water test, pH, chloride test, sulfate test. In fine aggregate, we use test C1 lysis, specific gravity. In aggregate test, the specific gravity, crushing test, impact test, and water absorption tests were conducted. In water, the pH values of water indicates hydrogen ion concentration in water. For our water testing, the pH reading is about 7.2 to 7.4. In determination of chloride, for a standard sodium chloride, the value we get is about 28.3 and the sample is about 5.9. For sulfate, in the cement, we use the sulfate present in 10 ml is about 9.44 gram. Test conducted on water, the permissible limit for the chloride test is about 250 milligram per liter, and for sulfate test we get about 90.44 milligram per liter. For permissible is 200 milligram per liter. For the consistency result is about 32%, and initial setting time is 32 minutes. Final setting time is about 580 minutes. For coarse aggregate and fine aggregate, we found the specific gravity for fine aggregate is about 2.7. It is between the permissible limit. Specific make 27 accelerated corrosion method. An electrochemical method was used to accelerate the corrosion of the reinforcement bars. The specimen were fully immersed in an aqueous solution of sodium chloride. The accelerated corrosion process was carried out with the help of NaCl solution by the weight of cement, and electric current is passed through the steel rebar for undergoing corrosion. Finally, the mass loss was calculated using Faraday's law. The mass loss formula is about this. Corrosion rates. We use for several groups, for about 7 groups, and morality of NaCl we added about 0.5 ratio. Corrosion rate is about 8.216, 7.75 percentage values. Faraday's mass loss. The mass loss formula is about this, and for several groups as x-axis and a percentage of mass loss in y-axis, and we attain some graph. Pull-out test. The test specimen shall be mounted in a suitable testing machine in such a manner that the bar is pulled axially from the cube. The end of the bar at which the pull is applied shall be that which project from top face of the cube was cast. By using the pull-out test, the bond behavior between HYST steel bars and concrete was analyzed. The bond stress will be calculated by using the formula as bond stress formula as ultimate load divided by area. The average bond stress of the corroded specimens, for group 1 we reached about 8.216, and for group 2 7.7 megapascal in about megapascals. These are the graphs we attained for several ratio of NaCls we added. Conclusion. The behavior of concrete made up of 100% of M sand embedded with high yield strengthening deformed steel rods is to be calculated experimentally. With the help of pull-out test, the variation of bond strength is calculated. The bond behavior of specimen by using M sand with corrosion for different corrosion rates is performed. These results are compared with the specimens without corrosion to identify the bond behavior between steel bar and the concrete. From this comparative study, the average bond strength value is increasing for initial corrosion rates, and it is followed by decrease of or higher corrosion rates. This initial increase in bond strength is due to the formation of corrosion layer between the steel and the concrete. The bond strength values we for 5% for 0. Mole NaCl when compared with uncorroded specimens increases by 8% for 1 m NaCl, 8.5% for 1.5 m NaCl increases by 34%, and 2 mm NaCl increases by 18.7%. For 2.5 m NaCl increases by 10.8%. For 3 m NaCl increases by 1.5% for 3 m NaCl. Thank you.
Okay, since we have let's have the question session at the end of the other 3 presentations. Now let's start with the second presentation, that is Mr. Anto Satish, Kannur A, and Arnalapundam V. That is, the paper is Effect of Textile Sludge in the Development of New Building Material as Polish Block Bricks. Now let's start with the second presentation, please.
Sir, shall I start?
Please go ahead, start. Is it Anto Satish presenting or Arunan Pandyan's presenting?
Sir, Anto Satish Kumar, sir.
Okay, please start this your presentation, sir.
Oh, okay, sir. Thanks. Good afternoon, one and all present here. Our topic is effect of textile sludge in the development of new building material as fly ash bricks. And myself, Anto Satish Kumar, along with Arul Pandyan, we are from Civil Engineering Department, National Engineering College, Koilpatti, Tamil Nadu. These are the contents I covered in the following slides. Let's see one by one. And the first one, abstract. The reason trend is waste management is to reuse the industrial waste into usable products. Sludge is generated in common effluent treatment plant of textile industry. The physical, chemical, engineering properties of this material will be analyzed from EDS or EDX and some analysis. And the compressive strength was conducted as per Bureau of Indian Standard to evaluate the suitability of above material in structural application. It is concluded that a maximum of 12% of sludge can be added in the bricks. The preliminary results were encouraging enough. Along with the results, our further research in terms of permeability test having studied to recognize this a non-toxic building material. The material not require thermal energy for binding. It consumes 7,000 ton of firewood and air curing is sufficient for 14 days only. And next, introduction. The textile industry is one of the oldest and largest sector in India and goes in association with Silk Route connecting India and China. At present, the textile units are scattered all over India. Out of 21,076 units, Tamil Nadu alone has 5,285 units. We use flyers, quarry dust, and textile sludge. Having explored various literature, we commented the research works were done only in the manufacture of conventional band clay bricks. So we figure out up to 15% of textile sludge is required for the suitability of compressive strength. The study proves that increase of sludge proportion results in the increase of weight loss on ignition in terms of percentage. Let's come to the objective. Our objective to utilize the waste material produced from industry in the construction field. Transmission of such solid waste from effluent into construction material might yield to the culture of prevention and conserving the mother nature. And specific objective to manufacture brick using the textile sludge, waste and fly ash to study the effect of sludge on the plasticity index of the brick, to carry out the experimental investigation on the brick to test its compression, water absorption and permeability, to save thermal energy which amount to 70 ton of firewood for firing 1 lakh bricks. The new process does not require firing. These are the material we use: flyers, quarry dust, and textile sludge. We converted into the textile sludge into powder form. And let's first one, flyers. Flyers are highly dispersive powder. These byproducts are dumped in large scale in every thermal power station. For the current research work, these flyers from thermal power station are obtained and will be utilized in the manufacture of bricks. Flyers, which are generally spherical, these small glass spheres improve the fluidity and workability. And quarry dust. In stored cluster quarries, a considerable amount of quarry dust is produced as byproduct. Currently, most quarry dust is disposed of in sanitary landfill or it is open dump in the uncontrollable waste pits and open area. Sustainable amount of this powder have accumulated and its utilization pose an important problem. Hence, such powder emission produce air pollution at quarry and quarry dust. It does not combat as well as other material and sludge. The study proves that the effluent having disposed from the industry contain lots of pollutants such as sulfate, chloride, and color. Hence, this effluent having dumped into the land which maximize the contamination and escalate the environmental issues. Effluents having collected from common effluent treatment plant in different parts of Tamil Nadu. Therefore, these effluent act as a building material in the manufacture of bricks. And let's come to the mixed proportion for fly ash and bricks. Quarry test ratio. This is the graph plot between water flyers and quarry test. Here we used 3 different percentage of sludge like 5, 7 and 8. And finally we taken as a 3 as a optimum one. Here we see before and after 3%, it get vary. And come to the next one. Here the plot draw between the water sludge and quarry test. Here also we use same percentage, and here also we get the same 3% as a optimum. And we finalize the 3 as a optimum, and we go for 3 ratio 1:3, 1:2.5, and 1:2. And casted bricks. The size of the bricks of 220 crust 110 into 80 mm. The hydrostatic pressure applied to make the brick was 180 kilogram per centimeter square. And the results. Having analyzed the strength of brick, we discovered that the brick remained inadequate to achieve the required strength as per IS norm. So we plan to add additional 2 material like lime and gypsum in addition to existing the raw material. We eventually obtain the desirable result in the further addition of lime and gypsum. In other words, further addition of lime and gypsum to existing new material intended to enhance the required strength of the flyers bricks. And these are the images. And we do some analysis to find the particle separation. It shows particle size inside the structure. And the first image is 10 micron distance, and another one is 20, likely 5 micron and 2 micron. And some analysis for lime, here 2 micron and 10 micron. And finally, we conclude there is no separation of particle inside the structure. And then comparison of textile sludge and lime. Here we saw the bar chart, and the most variation is occurred in the calcium. Calcium may affect the environment, may cause environmental issues. And experimental investigation, compressive strength test, water absorption test, and determination of effluents. And compressive strength. In y-axis, compressive strength, and x-axis mixed combination. Here we use 6 different combination and find the 7th day and 14th day compressive strength. And water absorption test and effluents. The soluble salts being present in bricks will cause effluents on the surface of bricks. For finding out the presence of soluble salts in bricks, these tests were carried out. The bricks are immersed in water for 24 hours. Then the brick were taken out and allowed to dry shade as per IS norms. And as per IS norm, the liability to effluents shall be reported as nil, slight, moderate, heavy, or serious. Here we get the result as nil. And cost analysis, without transport, labor, and current cost. Here we finalize the C1 for the better cost per pick. And finally come to the conclusion. The result of the brick 1:2, 1:2.5, and 1:3, with one part being flyers and the other as quarry test. In addition to the textile sludge was added in the ratio of 7%, 10%, and 15%. The shape of the brick was well obtained, but does not attain the maximum strength of 3.5 Newton per mm square as per IS. The failure may be attributed to the inadequate requirements of textile sludge. The lime and gypsum were added as additional ingredient only to increase the setting time of the fly ash brick. The study has plastic limit confirmed the ratio of fly ash to quarry test commercially followed in the manufacture of fly ash bricks. From the results, it can be seen that 1:2 ratio, that is C1 mix of fly ash to quarry test with textile structures 12%, along with the lime of 5% and gypsum 2%, give the best result confirmed to IS 3495 for bricks.
Okay. Thank you, Mr. Antonis Satish.
Thank you, sir.
Thank you very much for your well presented your work. Now I call upon Bahan Edin Gravity, Mustafa Dad, Bashir Aldawala, Manas Ranjan Das, the authors of the paper titled Developing Local Rubber Mixture for Seismic Based Isolation System Type HDRM. Okay, to be presented. Who is presenting it, sir? May I know who is speaking here? Who is going to present it? Can you hear me?
Sorry. I was muted.
Okay. Who is going to present your paper?
Fahad bin Al-Wadisi.
Okay, you can start your presentation, sir.
Thank you, sir. Good afternoon, all. I would like to thank you for giving me a chance to present my article, which joins between mechanical and civil engineer together, entitled Developing Local Rubber Mixture for Seismic Base Isolation System Type HDRP. Contains introduction, criteria of choose isolator, developing the rubber mixture, technical and mechanical properties, and conclusion finally. Seismic isolators are elements put between foundations and structure. Their job is giving a tilt horizontal move to the building to increase the period and absorb the energy which is transferred to the building in horizontal direction. The isolator consists of steel and rubber layers alternately, as shown in this figure. This video shows the manufacturing process of the isolator, where we put the steel and rubber layers alternately. This video shows also the difference between and isolated building, where the objectives of isolators are avoiding human usage and decreasing of building failure. The isolators increase the building period that lead to decrease the acceleration and the horizontal load as well. And the damping ratio for isolators between 5 to 30%. This is a table from company which produces several kinds of isolators. The table has many important details like damping ratio, the displacement. Also, this is the critical displacement, dimensions of the isolator, diameter and height, also vertical and horizontal rigidity. This figure shows the relationship between horizontal force and the diameter. So we choose our isolator with diameter of 150 millimeters. This is the dimensions of our isolator with all details, the upper and lower length, the thickness of rubber 8 millimeters, and for steel is 2 millimeters. The rubber mixture contains several materials with specific amounts like rubber, carbon, sulfur, oil, with specific percentage depending on the rubber amount. The relationship between horizontal load and displacement is known by statistical rules, and we can see the most bending kind of isolators is lead rubber bearing. Then we can see HBRB, which is high bending rubber bearing, which is our isolator. Then the low bending one. The statistical rule created by cyclic load per system is loaded here. Then we unloading, and finally we reloading again. This green area expresses the amount of energy dissipated. This is the experimental result of our isolator. And we can find the mechanical properties by these two equations, where the vertical rigidity should be greater than 50 kilonewton per millimeter, and the damping ratio also around between 5 and 30% as we seen before. After finding the experimental results, we compared it, and it was logical. This video shows the experiment of isolator. This isolator used in Budi Hospital. Experiment 1. You can see here the isolator diameter is 1 meter and 30 centimeters. And the horizontal displacement, the critical displacement is 1 meter. And he can get vertical load which reach to 2,000 tons. Conclusion. As a conclusion, the difference between two forces in both negative and positive directions of the same load is explained by several causes, such as reading error and because pressure measurement. The experimental value of horizontal and vertical rigidity and shear factor of experimental model are logical and close to global standards. The difference of forces values between loads refers to the energy which is absorbed by rubber, which means the broken down of carbon found in the rubber material. Comparing experiment results with international tables of manufacturing companies was almost identical. And the manufactured rubber mixture is in this research is convenient, giving a great motivation to manufacture seismic isolator locally with acceptable prices. Thank you. Yes, sir. Hello. Any question, please?
So please stop sharing your screen.
I have already stopped sharing. I'm not sharing my screen.
Sir, we are not able to.
I'm not sharing. Oh, sorry. Yes. It's fine now?
No, we are not
Sir?
unable to see. You are not sharing the screen, sir.
I stopped the screen. I stopped sharing. It wasn't visible.
No, not yet. It's not been sharing. No,
When I present, it wasn't sharing.
no, sir.
Why no one told me?
I'm unable to. You are not sharing the screen. Would you please share the screen of your presentation?
Let me. Now it's sharing or not?
Yes, sir.
Is it visible? And now it's visible.
Yes, yes,
Yeah.
yes, sir. It
Now
is.
we can see.
I will go. I will go first. Fast. Okay.
Yeah.
Introduction. Seismic isolators are elements put between foundation and structural. Their job is giving.
This part is over. This part is over. Would you please? Corrosion is also over. Would you please proceed? Come to the conclusion, sir.
Okay.
Come to the conclusion.
Okay. Yes, sir.
Yeah, please. Go ahead.
Sir, could I present fast? It will take 5 minutes only.
Yeah. Please conclude. Please conclude your presentation, please.
The difference between two forces in both negative and positive directions of the same loop is explained by several causes such as reading error and uh, erosion, inaccuracy of region management. The experimental values of the horizontal and vertical rigidity and shear factor of the experimental model and the logical are logical and close to the global standards. The difference of forces value between loops refer to energy absorbed by rubber, which means the broken down of carbon found in the rubber material. Comparing experimental results with international tables of manufacturing companies was almost critical, and the manufactured rubber mixture in this research is convenient, giving a great motivation to manufacture seismic isolator locally with acceptable prices.
Okay, sir. Now, please wait until the fourth speaker is completed so that the questions could be asked by the participants. Please kindly wait. Let the fourth speaker present his paper.
Okay.
Now, the author is Ambati Supraja. Please kindly present your paper, madam. It is about static and dynamic analysis of the transmission tower with and without cyclonic effect. Kindly present the paper. Ambati Supraja, can you hear me? Hello? Ambati Supraja, can you hear me? Please present your paper, Static and Dynamic Analysis of Transmission Tower with and Without Cyclonic Effect. Would you please present the paper, please?
Sir, I don't think the presenter is there in the meeting, sir.
Okay. Okay. Madam, can we start for the question session to start now?
Yes, sir.
Okay.
You can
Vishnu Prakash, your paper, Experimental Study on Bond Strength of Reinforced Cement Concrete Using M Sand Under Corrosion. Okay. Now the participant can ask questions with regard to this work. You can type in your questions so that Vishnu Prasad would be able to answer them.
Sir.
Vishnu Prasad, now would you please, there are a few questions to be asked by the participants.
Okay, sir.
They are typing it. Would you please wait a minute, please? Meanwhile, Dr. Jyoti ma'am, would you please, is there any questions so that you could ask Mr. Vishnu Prasad?
Ma'am, switch on your mic, ma'am. Jyoti ma'am.
Jyoti ma'am, would you mind switching on your...
Yeah, sorry.
Okay.
Nice presentation, Vishnu Prakash. I had one query. You had mentioned that molarity of sodium chloride, as it increases, corrosion rate has reduced. What may be the
yes, ma'am.
What may be the reason, and what is the contribution of M sand here? That clarification can you give? What is the contribution of M sand here when the molarity rate of NaCl has increased? Because you have started from 0.5, right? 0.51, 1.52. What may be the reason why the
yes,
when
ma'am.
the molarity
While
rate was
using
only 0.5?
Polarity rate while 0.5 the strength is increased, ma'am. By going on, it can decrease, ma'am. At last.
That's what. What is
because
the corrosion rate?
Reverse sand is nowadays.
Yes,
corrosion rate only, ma'am. First at starting it will increase, ma'am, by using low moles of NaCl by about 0.5 mole, that 1 mole. Then by adding extra moles of NaCl, it may decrease, ma'am. The corrosion rate increased, ma'am.
Corrosion rate has?
Ma'am, by adding extra moles of NaCl, the corrosion rate increase, ma'am. At first, by using less NaCl, the corrosion rate is less, ma'am.
Okay, sir, that's all from my side.
Anybody else from the participants?
Right.
Okay. Now we'll come to the second paper, that is effect of textile sludge in the development of new building materials as fly ash. Now, Anto Satish, are you there?
Yes, sir. I'm there, sir.
Okay. Participants can ask for the questions, please, so that Anthony Satish would be able to answer. Okay, Mr. Anto Satish, if there is any questions, they will mail it to us and we will mail it back to you so that you will be able to answer those questions given by the participants. Okay, sir?
Okay, sir. Okay, sir. Thank you, sir.
Okay. Meanwhile, the fourth paper presenter, Ambati Supraja, has they joined? Amrita Supraja, Ambati Supraja, have you joined? If you have joined, you can present your paper. Okay. Now, since they haven't replied, let's go to the question and answer session of the third paper. That is.
Sir, sorry to interrupt. I have few queries regarding second paper, sir.
Okay, ma'am. Sorry, madam. Sorry.
It's okay.
Anto Satish, are you there? Mr. Anto Satish?
Yes, sir.
Would you answer a few questions put forth by Dr. Jyoti, ma'am?
Yes, sir. Yes, sir. Yes, sir.
Jyoti, ma'am, you can ask.
Yes, sir. Yes, yeah, yes, sir. Organization of PPT was very good, Satish. And I would like to clarify a few things that you had mentioned in your introduction part that the research has been done on only fire clay bricks. Sorry, lot of research has been carried out on non-fire clay bricks also. And the sludge photograph which you showed, it does not look like, it looks like a lumps of stones. Sludge means it should be wet, no? Had you dried it or what? It was not looking like a sludge. It was looking like a lumps of stones, the textile sludge.
Yes, ma'am. Is tried.
You had dried it and crushed into fine powder, is it?
Yes, ma'am.
Okay, okay. And you had compared the textile sludge with the lime. And you told that it is almost same. The properties of textile sludge and lime was same. So instead of using lime and gypsum together, you could have tried one more option, no? Only gypsum, textile sludge, quarry dust, and fly ash. Did you try that?
No, ma'am.
Because in your PowerPoint presentation, you had mentioned that properties of textile sludge and lime was almost same, right?
Yes, ma'am. But the calcium variation is high, ma'am.
Calcium was?
Ma'am, calcium variation is high bar lime, ma'am.
Okay. And
But compared to textile sludge, it is average.
Okay. How much was the calcium content in textile sludge and how much was in lime?
Ma'am, for textile sludge nearly 40 and lime 25 to 30, ma'am.
In lime, it was 25 to 30. And in textile, it was 40 to?
Above 40, ma'am.
Okay. Then already calcium was there, no? What was like, why you added lime again? You could have added gypsum, no, instead of that. You could have tried that option also. That's what I meant. And what was the final strength you got for this? You told that textile 12%, lime 5%, and gypsum 2%. You got a good strength. What was the compressive, wet compressive strength you got for this proportion?
Ma'am, more than 3.5 Newton per mm square, ma'am.
Okay, so it was satisfying the IS code provision, right?
Yes, ma'am.
Okay, good, good.
Okay, ma'am. Thank you.
Okay.
Okay. Okay, the third paper presenter, would you please answer a few questions put forth by the participants? Ma'am, you can also, Jyoti ma'am, you can start asking the questions.
Yes, sir. Sir, in the chat box, I saw Professor R. Nagendra sir had asked few questions
okay.
To the participant, first participant and third participant also, I think.
Okay, okay. In the chat box, you able to see it? Mr. Vishnu Prakash, are you there?
Is there M sand composition is active in corrosion? If yes, how? That is what the question asked by Professor R. Nagendra. To Vishnu Prakash sir.
Okay. Are you there, Vishnu?
Hi, yes, sir.
Okay.
Hello, sir.
Yeah, gentlemen, continue.
Yes, sir. is there M sand composition is active in corrosion? If yes, how? This is a question asked by Professor R. Nagendra to you, Vishnu Prakash.
Okay, ma'am. And why? Yes, ma'am. M sand composition is active in corrosion only, ma'am.
How?
Because ma'am, by using corrosion reinforcement as M sand, by using river sand, it is somewhat high only, ma'am.
Compared to river sand, M sand, the corrosion rate is?
Ma'am, the two are same only, ma'am. But nowadays, availability of river sand is not available more, ma'am. So only we use M sand.
Okay, okay. Sir, Nagendra sir, can you unmute yourself? Are you satisfied with this answer, sir?
Vishnu Prakash, my question is, what is the composition? I'm not asking what is river sand, what is M sand. The M sand is nothing but a composition from the different materials. Either it's a granite or an ices, which will be powdered and make into a your gravel size or a sand size. So my question is whether that composition is an active during corrosion. I think you understood my question.
Now understand, sir. Sir, it is active only, sir. Because
if it is active, how? Is it a feldspar present in the M sand is active, or quartz is active, or mica is active? If it is so, what is the percentage of its activeness? Can we remove that material and to use for this purpose so that we will not have a corrosion at all?
Yes, sir.
Okay, anyway, you can look into this. Logic, the composition of M sand, what is the percentage is more, whether that particular component is active during the corrosion. If it is active, if you can remove that particular percentage, can it able to use it for your purpose? Okay?
Okay, sir.
Okay,
okay,
fine.
sir. Thank you, sir.
Yeah, fine. Thank you.
Vishnu Prakash, take this suggestion.
Thank you, sir.
And try to incorporate it. Okay? Thank you, Professor Nagendra sir. Thank you very much.
Thank you, sir. Thank you, sir.
Okay. Ma'am, Jyoti ma'am, would you please ask the questions on developing local rubber mixture for seismic-based isolation system type STRB? Would you please ask the questions, please?
Yes, sir. Yes, sir. It was a good presentation, but I did not understand, like, how did you manufacture that local rubber mixture isolator, and how did you procure the raw materials? What was the testing equipment used to test, and how did you check its quality, durability, and cost, whether whatever is available in the market, what you are telling that it is locally manufactured. So have you done any cost comparison of the local rubber isolator, what you have manufactured with the market, available isolators in the market?
Okay, thank you, ma'am, for the question. Actually, the rubber manufactured by companies which don't tell anyone how they manufacture the rubber and the percentage of materials which go through the mixture of rubber. So I showed table with the specific percentage of the materials which is like sulfur and oil and reaction accelerator. These materials, when we mix it in a specific percentage, we will get the good mixture rubber, which is we can compare it with international companies, which produces isolators. Actually, there is many tables. I show also table one of manufacture. The results which I had got, it's near to the company's results. So we don't have to import from outside international companies. We can use this mixture locally without export the isolator from outside. And there is a question about the environments. Actually, the most dangerous for rubber is the lower temperature, around 4 Celsius. The rubber can hold the high temperature around 40, 50, but the most dangerous one for rubber is the low temperature.
Ma'am, do you have any few questions more?
No, sir. Sir, again, Professor Nagendra, sir, he had asked one question.
Yeah.
What may be the durability of rubber under varied environments?
Yes, ma'am. I answered it by high temperature and lower temperature. So the environment when the climate was very cold, it will damage the rubber.
Sir, that's all from my side.
Okay, thank you very much. This concludes the first session, the first technical session now. The second session starts at 3:15 p.m. Okay, thank you very much. I thank Vishnu Prakash, Anto Satish, Edin Gravity for presenting their paper. Well, and one paper, Ambati Supraja, was not able to come. Thank you very much. Thank you very much, Jyoti ma'am.
Thank you, sir. It was a pleasure to sharing the platform with you.
Thank you, ma'am.
Thank you, sir.
Thank you. Thank you.
I thank Dr. P. Prakash and Dr. Jyoti TK for chairing our technical session. We shall join back for the technical session 2 at 3:15 p.m. Thank you all.